Namaste. This is JB and Dr. Vishal Saxena, Professor in Mathematics in the Faculty of Education and Methodology, JAYOTI Vidyapeeth Women's University, Jaipur. Today I'm going to discuss on the module the basic concepts of probability and the some basic definitions. This module is a part of the course research methodology and biostatistics and under the program of BPT 6th semester and B pharmacy 8th semester of the university. So probability is a very important concept of mathematics and as well as statistics. So the today's lecture is just about the basic concepts of probability and their basic definitions. And today we are discussing on these concepts and what is meaning of probability, and we take some examples to explain this. So for this, I'm going to share you some slides. So look, the first, what is probability means? The probability first, we define probability, and before this, just we are going to define some basic concepts of probability and related concepts. Like first one is the probability event. The probability events means it is a set of the outcomes of an experiment. So when a random experiment or simple experiment is performed, then what are the set of outcomes? Just the set of outcomes is called the probability event. So this is the probability event means a set of outcomes of an experiment. For example, just when we take a dice and we throw it, then certain possibilities are there, like coming of when we take a dice and we throw it, then certain possibilities are there to come, like coming of one or the two or the three or the four or the five, six. So these are the six possibilities to display on the dice, and these six events, these six outcomes can be taken as the events or the probability event. Uh, Next, the entire possible set of outcomes of a random experiment is the sample space. So one of more again an important definition of the probability, that is the sample space. So sample space means the entire possible set of outcomes of a random experiment. Like for example, suppose just we roll a dice, then there are six possibilities of coming the number, means 1, 2, 3, 4, 5, 6. So if just a set is made with all the possibilities of outcomes, means 1, 2, 3, 4, 5, and 6, then this is called the sample space. So sample space means the possible set of the set of all the possible outcomes. Then the sample space for the tossing of three coins simultaneously is given by. Now we take one more example. For this, suppose we are having a like we have three coins and then we roll it. Okay, we roll it. So it means just when we roll the three coins, then what are the possibilities of coming there? So maybe three heads, maybe two heads and one, two tails and one head. Then THT means tail, head and tail, and tail, head and head. Then tail, head and head, head, tail and tail. And in this way, just we can see there are certain possibilities of coming of these three like events on the three coins. Just ultimately a set S, which is called a sample space, is consisting of all the possibilities of just coming of three heads or three tails or two heads or one tail and in the just arrangement form. So that is called the sample space. Now, next we are going to discuss the simple event and the compound event. Simple event means any event consisting of a simple point of the sample space is known as a simple event in the probability. So, for example, just if we take S equal to, look at this one, 56, 78, 96, 54, and 89. So, sample space S is consisting various events here. So, various these possibilities like 56, 78, 96, 54, and 89. So, and E is equal to 78 means just taking one of the possibility, taking one of the option there in a set form, and that is E there. So just E is called consisting a single point, single event is called a simple event. While what is meaning of compound event? Just contrary to the simple event, if any event consists of the more than one event, one single point of the sample space, then such an event is called a simple is called compound event. And suppose in the just previous example we have discussed, if S is given by 56, 78, 96, and 54, and 89. So there are five possibilities, there are five events in the sample space S. And if we take two events, E1 and E2, E1 is consisting of 56 and 54, and E2 is consisting 78, 56, and 89. Then just the two events, E1 and E2, you can see this one because E1 and E2 are consisting more than one single point. And that's why these two events are called compound events. And the compound event means ultimately this event can be broken down just into the simple events. That means into the single point events. And these are the examples of the compound event. Now next we are going to discuss the mutually exclusive events. So what are the mutually exclusive events? So look at this one, mutually exclusive events means if the occurrence of one event excludes the occurrence of the another event. Such events are mutually exclusive events, that is the two events don't have any common event. Means if the two events cannot occur simultaneously, then the such two events are called mutually exclusive events. That means if two events are cannot occur simultaneously, then their two events are called mutually exclusive events. And for example, there, just suppose the sample S space S is consisting the events 1, 2, 3, 4, 5, and 6. The sample space S is consisting 1, 2, 3, 4, 5, and 6. And E1 and E2 are the two events such that E1 consists of the numbers less than 3 and E2 consisting of number greater than 4. So it means the event can be written in the mathematical form as 1 comma 2, 1 comma 2, and event E2 can be written as 5 comma 6. So then the two events E1 and E2 are mutually exclusive events because the two events does not have any common number there, any common element there. That's why just these two events are called mutually exclusive events. Next, exhaustive events. Exhaustive events means a set of events is called exhaustive if all the events together consume the entire sample space. Means if a set of events is called exhaustive, then it means it consists of all the events together consume the entire sample space. Means the exhaustive events means if all the events together consume or just will provide the entire sample space, then it is called these events are called exhaustive events. Next, we are coming on the concepts of the probability. So look at this one, probability. Probability is a very important concept of the mathematics, and it just relates with the chance of occurrence. So probability implies a likelihood or the chance. Probability means it implies a likelihood or the chance. When an event is certain to happen, then the probability of occurrence of that event is 1. And when it is certain that the event cannot happen, then the event probability of that event is 0. So probability means it implies the likelihood or the chance of occurrence of events. So when just an event is certain to happen, then the probability of occurrence of that event is 1. Because if some event is just the chances of occurrence of that event is complete, then it means its probability will be 1. And when it is certain that the event cannot happen, means if the event does not happen, then its probability will be 0. So ultimately, probability range is between 0 and 1. From 0 to 1, that is the probability event, the range, and now formula. So PA is equal to number of favorable cases divided by total number of equally likely cases. So just probability of event A means the total number of favorable cases to that event and divided by total number of possible outcomes, or total number of equally likely cases. That means it is equal to m by n. So this is the concept of the probability, and that is the probability definition. So it is the number of favorable cases upon total number of possible outcomes. That is called the probability. Next, a sample space, simple example to tossing of a fair or the unbiased coin. Since the coin is fair, the two outcomes, heads and tails, are the both equally probable. Therefore, it means the probability of heads equals to the probability of tails. Because when a fair coin is taken and it is thrown, then the two possibilities are there, coming of head and the coming of tail. These are the two possible events, and the two events are having the probability equal to 1 by 2. Because for the both events, the chances of occurrence there are 50%, means 1 out of 2. So the probability for the coming of head is 1 by 2, and the probability for coming of tail is again 1 by 2. And since no other outcomes are possible, so therefore the probability of either head or the tail is 1 by 2, and it means it can be written as 0.5 or the 50%. Next, we discuss the applications of probability. So probability theory is applied to everyday life in the risk assessment and the modeling. So probability theory is applied in the everyday life in risk assessment and the modeling, and the insurance industry and markets use actuarial science to determine pricing and make trading decisions. Governments apply probabilistic methods in the environmental regulations, entitlements analysis, and the financial regulation. The probability of an event A is written as PA. So ultimately, probability of any event A is given by PA, and probability theory is applied to various events like in the risk assessment and the modeling. The insurance industry and markets use actuarial science to determine pricing and make trading decisions. Besides this, the meteorology department also uses the concept of probability for the forecasting, forecasting of rain and forecasting of clouds, forecasting of just any other like event. In the same way, so in the different like fields, the probability is having many applications. Now, one example we take. So one is here, just we take this example. In the game of snakes and ladders, a fair die is thrown. An event even represents the event of getting a natural number less than 4. So just less than 4 means this is a question for the dice natural number. A game of snakes and ladders means a die is thrown. So what is the sample space? Sample space means 1, 2, 3, 4, 5, and 6. There are 6 possibilities. Then event even means 1, 2, 3. 1, 2, 3 are the events for the sample space S. E2 means 2, 4, 6. E3 means 1, 3, 5 according to given condition, because even is representing the events of getting a natural number less than 4. So just 1, 2, 3. Then E2 consists of all the events of getting an event number, even number. So it is 2, 4, 6. And E3 denotes all the events of getting an odd number, means 1, 3, 5. Therefore, even or E2 or E3 means that is 1, 2, 3, 4, 5, 6. So these are the like possibilities for the events. Even or E2 or E3 means just we can say this is called the union property. So even or the E2 or the union E3 means combining all the possibilities. Even and E2 and E3 means their intersection point, their common events, but even and E2 and E3 means even intersection E2 intersection E3, and there is no common element in the 3 events, therefore this equal to 5. Third is even but not E3. Even but not E3 means that is the possibility which is coming in even but excluding E3. So that is coming there. What is coming there? 2. So 2 is coming there just because 1 and 3 are just deleted. These are the common. Therefore, only 2 is in this event which is given by even but not E3. Next is here for independent events. For independent events, now we are taking the 2 more concepts. One is for independent events and for the dependent events. The theorem states that the probability of simultaneous occurrence of 2 events that are independent is given by the product of their individual probabilities. So it means PA and B is equal to PA into PB. In the case of the independent events, the probability of 2 events in this multiplication, PA and B, or their combined probability, probability for the combined event A and B is equal to PA into PB, and just it is the law for the 2 independent events. In the same way, if we are having the 3 events A, B, C, and these events are independent to each other, then PA intersection B intersection C is equal to PA into PB into PC. So if the 3 events A, B, and C are independent to each other, then it means PA intersection B intersection C means PA into PB into PC, and these are the for the independent events. Next, for the dependent events, conditional probability. As defined earlier, dependent events are those where the occurrence or the occurrence of the event affects. So just means we have discussed about the independence events. Independent events means these are the just events in which means one event, occurrence of one event does not affect the second event. And the occurrence of the second event does not affect the first event. So that is the just independent events. So independent events means those events which does not affect each other, and therefore PA intersection B intersection C equal to PA into PB into PC. Next, for the dependent events means for the conditional probability. For the dependent events, we have to understand what are the dependent event means. Dependent events are those events means where the occurrence of first event will affect the occurrence of the second event, and the occurrence of the second event will affect the occurrence of the first event. So the occurrence of the first event will affect the second event, and the occurrence of the second event will affect the occurrence of the first event. So just such kind of two events are called the dependent events. And for the dependent events, dependent events are those where the occurrence of non-occurrence of one event affects the outcome of the next event. And for such events, the earlier states multiplicative theorem is not applicable, and the probability associated with such events is called as conditional probability. So it means we have to understand what are the two possibilities. For this, how the multiplication property is defined for the dependent events. And before this, we now define the conditional probability. So conditional probability is written by PA by B. PA by B is the conditional probability of event A with respect to event B. So probability of event A with respect to event B is written by PA by B, and this equal to PAB upon PB. So in the numerator, what should come there? PA intersection B, PA intersection B divided by probability of B. PA intersection B upon PB, and this is called the probabilistic probability for the event A by B, and PA by B is called the probability of occurrence of event A when event B has already occurred, or when the event B is compulsorily to be attached with event A. Means when the event B has occurred, then PA by B is showing the probability of event A. And similarly, now we can say this one, PB by A is equal to PBA or PAB upon PA, or just we can write PA intersection B upon PA. When we just in this way, we have defined the conditional probability for the event B when the event A has already occurred, or we can say the probability of event B, PB by A, showing that the probability of event B when the event A is attached with event B. So that is called a probability of conditional probability of B by A. So now when we simplify this term, and if PAB is given by, or PA intersection B is given by PA into PB by A, PA into PB by A, or just in the above formula, PA intersection B is equal to PB into PA upon B, then this is called a multiplication theorem for the events, and just this is the part of basic concepts of probability and their basic definitions. So Today we have discussed about the probabilities and its basic definitions, basic concepts, and this is a very important topic. It is a conceptual topic. So with this, I'm concluding my today's lecture. Thank you.